In this video, we're going to work some word problems where we have to use either a linear equation in one variable or a rational equation to solve the problem. We're going to do an example of each of the topics that we talked about in the previous video or two videos before this, where we went through this section of the textbook. So simple interest, mixtures, distance equals rate times time, proportions, those topics. We're going to do one problem on each of those topics, and then in the next video, we're going to do another problem on each of those topics. All right, let's get started. Fernando invested money in a 3-year CD that returned the equivalent of 4.4% simple interest. He invested $2,000 less in an 18-month CD that had a 3% return. If the total amount of interest from these investments was this amount, determine how much money was invested in each CD. All right, so we've got this 3-year CD. So let's say that CD 3, and then if we look at this problem, he invested money in a 3-year CD. So, okay, we're trying to determine how much money was invested in each CD. So let's just say CD 3 is the amount of money that was initially invested in this 3-year CD. And then we also have this 18-month CD, and we'll call this, so 18 months is 1.5 years. We'll call this CD 1.5. Okay, so we can see that he invested $2,000 less in an 18-month CD, $2,000 less than the 3-year CD. So there's a relation or equation right there. So take CD 3 minus, subtract 2,000 from that, and you get what? CD 1.5. You see? The amount of money he invested in CD 1.5 was $2,000 less than what he invested in CD 3. That's what it tells you here. You have to you're trying to read the problem and rewrite the story, but in equation form. Okay. The interest earned, so let's say this is I3 and then I 1.5. That's the interest earned on CD 3 and CD 1.5. We know that the general formula that we saw in the textbook video was I is equal to PRT. T is in years, R is the rate, and P is the amount, the principal, or the initial investment. So like our P is going to be the CD 1.5 and CD 3. We'll have I3 and I 1.5. And then you can think of, we also have like R3 and R1.5, T3 and T1.5. We won't write out those variables, but you can think about it that way, right? Because like, what is R1.5 or R3? R3 is 3 years. R1.5 is this 1.5 years. Or no. That's T1 that's T3 and T1.5. R3 is this 4.4%. R1.5 is this 3%. You see? So what is I3? I3 is the amount of money invested in the 3-year CD. So that's CD3 times the rate of CD3, 4.4%. So 0.044 times the time, the amount of time to accrue the interest in CD3, 3 years. All right, and remember the idea, this is simple interest. You have an initial investment. If it earns this percent of that initial investment per year, but like you don't compound it, like you don't keep accruing the interest and then changing the initial investment, because it's simple interest, then you just say you take that percentage of the initial investment, but multiply it. If it's 10 years, then it'll be 10. You'll have that 4.4% per year for 10 years. You see, so you just multiply by the T in years. Okay, so we've got 0.132. Okay, let's see what else. So the total amount of interest from these investments was $706.50. So that's another easy equation. It's saying that I3 plus I 1.5 is equal to All right, so that's another equation. We have I3. What is I 1.5? All right, it's going to be CD 1.5 times the R 1.5, so this was 3%, times the amount of time for the 1.5 CD. Okay, so I 1.5 0.045. Okay, so what we can do is we can substitute this I 1.5 here. Substitute this I 1.5 here and this I3 here. And we'll get an equation that has CD 1.5 and CD3 in it. But then we also have this equation. We'll have two equations and two unknowns, and we can solve those two. Okay, so what is I3? 0.132 CD3. I 1.5 is plus 0.045. Okay, so now let's just substitute CD 1.5 in here, and then we'll have a linear equation in one variable that we can solve for CD3. So 0.132 CD3 plus, and this is CD 1.5 is CD3 minus 2000. There we go. This is a linear equation in one variable. Let's just solve for CD3. Okay, so we've got 0.132 CD3 plus, let's distribute this, so 0.045. Well, okay, we can just put 0.045 CD3 minus 0.045 times 2090. Okay, so now what is 0.132 plus 0.045? 0.177. Okay, now we'll add 90 to both sides, so 706.50 plus 90, 796.5. Okay, so now we multiply both sides by 1 over 0.177, or you can say divide both sides by 0.177, and we're left with, so 796.5 divided by 0.177, 4,500. This is dollars. So that's CD3. Okay. What is CD 1.5? CD 1.5 is just CD3 minus 2,000. Right? So there you go. That's our answers. The density and strength of concrete are determined by the ratio of cement and aggregate. Aggregate is sand, gravel, or crushed stone. Suppose that a contractor has 480 cubic feet of a dry concrete mixture that is 70% sand by volume. How much pure sand must be added to form a new mixture that is 75% sand by volume? Okay. So again, the best way to do this is this just told you a story. You want to rewrite that story with equations. All right, so let's go through this again. The density and strength of concrete are determined by the ratio of cement and aggregate. Right, ratio of cement and aggregate determines the density and strength of concrete. Okay, that didn't really tell us anything yet. Just gave us some information. Suppose that a contractor has 480 cubic feet of a dry concrete mixture that is 70% sand by volume. All right, so this is the aggregate is sand, gravel, or crushed stone. So the density and strength of concrete are determined by the ratio of cement and aggregate. The aggregate is like sand. The ratio of cement and aggregate. All right, so the contractor has 480 cubic feet of a dry concrete mix, but it's a mixture. This 480 cubic feet is 70% sand and concrete, right? The sand to concrete kind of ratio is 70% of it is sand, 30% of it is concrete. Okay, so you just got to read the problem. It's hard because I don't understand. I'm not a contractor, right? I don't understand concrete, so you just have to turn your brain on and read the problem. It's hard because now we have to do algebra too, right? But so you should understand what they just meant here. How much pure sand must be added to form a new mixture that is 75% sand by volume? So we're going to add pure sand because we want to increase this ratio from 70%, or not ratio, but the percentage from 70% to 75%. Okay, but here's the story. How much pure sand must be added? Okay, so let's say this pure sand that we're adding is X, right? X. This is the answer. If we solve for X, we're going to solve the problem. Okay? Now, what else? Well, let's do this. Let's say sand. This S, we'll solve for S. S is the amount of sand added. Okay? Now, the amount of concrete isn't going to change. We'll call that C. But like, we've got this original mixture of dry concrete, or just concrete, and that's not going to change because we're just going to add sand to that. All right, but that's the amount of concrete. So that's just another variable at the moment. Okay, so we've got these two variables. Now let's go through the problem again and see what we can write. Suppose that a contractor has 480 cubic feet of a dry concrete mixture that is 70% sand by volume. So by volume, that's key here, by volume. So in other words, what they're saying is, let's call S naught is the sand in the original mixture. So we're adding this, but this is the sand in the original mixture. And so what? But we don't need a C naught, right? We don't need that because this is not changing. This C is not changing, and these are the amounts. We're talking by volume here. So this is the cubic feet of sand added. This is the initial cubic feet of sand. This is the cubic feet of concrete that doesn't change. Okay, you got to really understand the problem. You have to read the problem multiple times to make sure you understand what it's saying. Okay, so suppose that a contractor has 480 cubic feet of a dry concrete mixture that is 70% sand by volume. So, okay, so S naught divided by what? S naught plus C. Right? The total volume, the initial amount of sand divided by the total volume of sand is 0.7. Right? And also, I just said the total volume. We know what the total volume is. S naught plus C is 480. There's another equation. You see? And what is it? Can we write another equation? How much pure sand must be added to form a new mixture? So this new mixture, what's the total volume of this new mixture? It's S naught plus S plus C, right? And then we put this 75% sand by volume, so S naught plus S. This is 0.75. There we go. Okay, so now let's see what we can solve for. We can put this S naught plus C right here. And what do we get? You get S naught over 480 is equal to 0.70. Well, this is a linear equation in one variable. It's the coefficient is 1 over 480 times a variable is equal to 0.70. I mean, to solve, if we want to isolate this S naught, just multiply the entire equation or multiply both sides, same idea. You're multiplying this side and this side by 480. So S naught is equal to 336. And this is going to be what? Cubic feet. So we can also now, we can come here. Let's put S naught here. So we've got 336 plus C is equal to 480. Let's subtract 336 from both sides. Okay, 480 minus 336. 144. That's cubic feet. All right, we're trying to find S. The answer to our question is S, though. So what do we need to do? Plug in S naught, plug in C, and we'll have it looks like a rational equation. So S naught plus S, 336 plus S, over S naught plus S plus C, 336 plus S plus 144 is equal to, okay, so 336 plus S over 336 plus 144, 480 over 480 plus S is equal to 0.75. Okay, so we need to multiply both sides, multiply this entire equation by 480 plus S. Or you can think about cross multiplying. So this is 0.75 over 1. You multiply 0.75 times all of this, and then 336 plus X times 1. Okay, but we get what? So we get 336 plus S is equal to 0.75 times 480 plus S times all of that, like as a group. Okay, so 336 plus S is equal to 0.75 times 480, 360 plus 0.75 S. Okay, let's subtract 0.75 from both sides. So we have, or let's subtract 0.75 S from both sides. So we have 1S minus 0.75 S on the left side, which is what? 0.25 S. And on the right side, we have 360 minus 336, which is 24. Okay, so now let's divide both sides by 2.5 or 0.25. And we get what? S is equal to 24 divided by 0.25 is 96. And that's cubic feet. Cubic feet of sand added. Right? What does this mean? It's the amount of sand, the amount of sand in cubic feet that we added to change the ratio from 70% to 75%. Okay, Darren drives to school in rush hour traffic and averages 32 miles per hour. He returns home in mid-afternoon when there is less traffic and averages 48 miles per hour. What is the distance between his home and school if the total traveling time is 1 hour and 15 minutes? Okay, so what is the distance between his home and school? So we'll call that D. All right, and so we're using this D is equal to RT. Right, if you drive for 50 miles an hour for 2 hours, then you've traveled 100 miles. That's the idea. Okay, so and you can rearrange it. You can divide both sides by R and get T is equal to D over R. You can divide both sides by T and get R is equal to D over T. Right? If you travel 100 miles in 2 hours, then you were traveling at 50 miles per hour. You divide 100 by 2. Okay. So looking at this formula, we can say what? We'll have RS is his rate traveling to school. 32 miles per hour on average. It's saying on average. And you know, and you can know on average because you know the distance, but if you know the distance between his home and the school in miles, and it took him 1.2 hours to get there, then you can, that's the, even though he's stopping and going and you know, sitting in traffic, sometimes going fast and other times, you know his average speed. Okay, so RS is 32 miles per hour, and then R home, his average rate going home is 48 miles per hour. Okay, now we're trying to solve for D, and it gives us, what else does it give us? The total traveling time. So the total going to school and coming home, the total traveling time. So that's another equation. So how can we get, we'll have what? We'll have time school, time home. Time driving to school, time driving home. And we know that TS plus T home is equal to, so 1 hour and 15 minutes. And we're going to leave this in hours. We're not going to convert this to minutes. What is 1 hour and 15 minutes as a decimal? So what is 15 divided by 60? One-fourth. Okay, so this is 1.25. This is 1.25 hours. Okay, so TS plus TH is 1.25. And again, we're leaving this in hours because we're working with miles per hour. So when we're multiplying things by these rates, we want it to be in hours. So we're not gonna say, you know, 60 plus 15 is 75. We're not gonna say TS plus TH is 75. We could, just depends on what, you know, just depends. So since we're dealing with miles per hour as our rate, we're going to leave this in hours. Okay, so we've got some different relations here. Let's make an equation for, well, okay. I mean, you don't have to do this, but you could say, like, if you have DS and DH, right? Well, we also know that DS is equal to DH. You don't have to put that, but if that helps you, you can put that. And that this is equal to D, right? We're trying to solve for D. So let's use this formula to write another equation. So we know that TS plus TH is equal to 1.25. So what is TS and TH? Right? Well, okay. We know we can take, just in general, T is equal to D divided by R. You divide both sides by R. Okay? So the D is the same though. So we're not going to put DS and DH, we're just going to put D. D divided by, what is RS, right? Because we're doing this TS plus TH. What is RS? This is TS, right? Well, let me do this. So, okay, TS is what? DS, but DS is just D, divided by RS, 32. Okay? What is TH? D, just again, D divided by RH. That's equal to 1.25. There we go. So now let's just solve for D, and we have our answer. This is a linear equation in one variable. This is 1 over 32D plus 1 over 48D is equal to 1.25. And you could also put this as, so 1 1/4. 1 1/4. How do you convert that to a fraction? That's 5/4. Right? 1 1/4. Multiply 1 times 4, add 1. You get 5/4. Okay, so let's solve this. We'll multiply the entire equation by the least common denominator. 48 is divisible by 4. 32 is divisible by 4. So we can just multiply all of this times 48. Or wait, no. No, so, okay, 32. So, okay, what is 48 times 2? 96. Is that divisible by 32? Yeah, so we'll multiply by 96. because then we get this is 96 divided by 32 is 3. So we get 3D, and then 96 divided by 48 is 2. Okay, and then 96 divided by 4 is 24, times 5 is 120. 3D plus 2D is 5D. Divide both sides by 5. You get D is equal to 24. That's miles. That's the distance between his home and school. One pump can fill a pool in 10 hours. Working with a second slower pump, the two pumps together can fill the pool in 6 hours. How fast can the second pump fill the pool by itself? Okay. Got it. Even I'm getting tired doing all these problems, but this is well worth the effort if you get good at problem solving like this. So pump 1. We'll have pump 1 and pump 2. What are these what are these variables? What does that mean? Well, okay, we're talking about a rate here. So let's see. Like, we're not worried about the volume because it's not giving. Sometimes we might be, but it's not asking us about any kind of volume. It's just a pool, right? We're talking about the rate of pump 1. Okay, the rate of pump 1 is, and I hesitate to put R because I don't know if this is distance equals rate times time. I guess it is. I don't. Maybe it is, but so what is the rate of pump 1? Pump 1 can fill. This is pump 1. One pool in 10 hours. Okay, so you can say it. The rate of pump 1 is, what is 1 divided by 10? 0.1 pools per hour. Okay, the rate of pump 2 is, well, we don't know the rate of pump 2, but we still have it as a variable. But it does tell us that working together, right? So all you do, you're just going to add that. Think about why, if they're working together and you want the rate, we'll just add those two rates because they're both working at the same time. R pump 1 plus R pump 2, right? So it's a little difficult to envision this because, like, well, if two bikers are traveling one biker is traveling at 10 miles an hour, the other's traveling at 20 miles an hour, so they're both traveling at 30 miles an hour. No, you can't say that, but it's like, think about it. Like if one pump can fill a pool, is one pool every 10 hours, and the other pump can do it this many pools per hour. If you put them together, you're just gonna you're adding it up to see how fast they're both gonna fill up, working at the same time. You just add the rates. Like, okay, if you have the exact same size pool, one pump can fill up one pool in an hour. The other pump can fill up one pool in an hour. Well, you put them together, it's going to do it in half the time. You put them together, they'll do it in 30 minutes. They'll fill up 2 pools per hour. You see? So we've got 0.1. Well, okay, no, let's just, RP1 plus RP2 is what? Can fill, it says the pool in 6 hours, so this is one pool. So 0.167 pools per hour. Okay, but we know RP1, right? So 0.1 plus RP2 is equal to 0.167. There's our linear equation in one variable. Subtract 0.1 on both sides, and you get, so this is 1/6 minus 0.1. So, I mean, let's do 1/6 minus 1/10. That's equal to, so how do we do 10/60 minus 6 60ths, 4 60ths, 1/15th. Okay, so RP2 is 1/15th. One pool in 15 hours. So that's the question. How fast can the second pump fill the pool by itself? In 15 hours, right? So you get the idea. If pump 1 by itself can fill the pool in 10 hours, and then if another pump in comes and helps it, and that time is reduced to 6 hours, well, how strong is that other pump? It would be one pool in 15 hours. Okay. I don't feel like reading this, but all right. In addition to measuring a person's individual HDL and LDL cholesterol levels, doctors also compute the ratio of total cholesterol to HDL cholesterol. Doctors recommend that the ratio of total cholesterol to HDL cholesterol be kept under 4. Suppose that the ratio of a patient's total cholesterol to HDL is 3.4, and her HDL is 60 mg per dl. Determine the patient's LDL level and total cholesterol. Assume that the total cholesterol is the sum of the LDL and HDL levels. All right, so I don't know what I'm going to put for variables here, but in addition to measuring okay. Determine the patient's LDL level and total cholesterol. So I guess we'll just use the variable LDL for LDL level, HDL for HDL level, and then just T for total. So we're trying to solve for T. Okay? Doctors recommend that the ratio of total cholesterol to HDL cholesterol be kept under 4. So I don't know why it gave us all this junk at the beginning. I don't think this has anything to do with the problem. It's just telling us just kind of backstory, but okay. Suppose that the ratio of a patient's total cholesterol to HDL is 3.4. So we're talking about this T is for this specific patient. So like this 4 is never going to come into play. I don't know why they told us all that. So T divided by HDL is 3.4. The ratio of a patient's total cholesterol to HDL is 3.4. And that makes sense because this is larger than this, so you're going to get something greater than 1. And her HDL is 60. So it tells us HDL is 60. So we can solve, and then it tells us here also that the total cholesterol is the sum of LDL and HDL levels. T is equal to LDL plus HDL. So this is easy, right? T divided by, just put 60. Okay, now we want to solve for T. Let's multiply both sides by 60, the entire equation by 60. So you get T is equal to 3.4 times 60. 204. All right, this is in mg per dl. All right, now let's just plug T into here. 204 is equal to, we don't know what LDL is, but we know HDL. All right, so let's subtract both sides by 60. Well, we can put it, to make it clear, we can do this. LDL plus 60, we can just reverse the equation. So we're solving for LDL, subtract both sides by 60, so we have 204 minus 60, 144. And that's what we're asked to find.